Question number 25. Okay. The positions of stable nuclei are plotted by neutron number n and p. NP graph is shown. The graph indicates a dotted line for which n equal to p. N equal to p. Okay. This graph is shown. This line is also shown. Okay. Fine. Okay. This line is shown. And which graph shows the line of stable nuclides and the shaded region. Okay. There are two parts in this graph. One is shows the line of stable nuclei. This should be a line. And the shaded region where the unstable nuclei emits the beta particles. There is a, you see, if I zoom into, I'll show you something here. Okay, this question has to be answered very carefully. If I zoom into here, you see, there is a line which is a dark line here. And above this, there is something like a shaded region. Okay, every graph has something like this. See, if I, let me show you each and every graph over here. Okay, so now let me just come out of it. How do I move it? Okay, fine. You see here, you can see there's a dark line and there is a shaded region here. You see there's a dark line and there is a shaded region above this dark line. If you look into this once again, I'll just move this here. Now you see there's a dark line and below this there's a shaded line and there's a dark line that is above the shaded line. I'll do one thing. To make it more clear, I will write something here so that I can clearly identify or let you know which is the right one. So I will just write this as a dark line and this is your shaded region, and here I will write dark line, shaded region, right? And here I will write this is my dark line, this is my shaded region, and here I will write dark line and this is my shaded region. Okay, now let me reduce it. Right, I have written it now. Okay, now we need to identify which one of them. Now as we know, okay, time is already up. Okay, fine, doesn't matter. So as we know that the stability criteria for the nucleus to be stable is nothing but the number of neutrons should be greater than number of protons. Okay, only then you can see the Colombian interaction can be minimized. You know, in a given nucleus, if I have two protons which are nearby, what can happen is there will be a Colombian interaction, there will be a repulsion between them, like charges, so they can move away. Okay, they can break the nucleus and rupture the nucleus and move away. So in order to prevent this, what we do is we put one neutron over here. We put a neutron and such that, okay, what can happen is the Colombian interaction can be minimized over here. More the number of neutrons, definitely the Colombian interactions can be minimized. But there is a catch here also. Okay, the nuclear force that we have in between, okay, it also exists between any two neutrons or between any two protons or between a neutron and a proton. It is very complex to understand the nuclear forces. Okay, and it is seen that they can be repulsive and attractive both. Okay, it binds the nucleus and at the same time there is a repulsive force also. And when you keep on adding number of neutrons, you can see the nucleus becomes more and more bulkier, very well larger. So it will not be able to tolerate beyond a certain value. Okay, so therefore there is a limit for the number of neutrons to be present over here. So this is all the theory behind it. Now when I say more number of neutrons are present, so when you have more number of neutrons, excessive neutrons will get converted into protons by emitting a beta particle along with it. Okay, so it will have an anti-neutrino also been emitted. So this is nothing but your beta decay that happens over here. Okay, so therefore neutron gets decayed into a proton and an electron and an anti-neutrino. That's what we have seen. Okay, so towards it, which of these will have this? So if you take up these graphs over here, the neutron number is lesser than the proton number. So therefore definitely A and B are the incorrect ones. Now if you look at these two appear to be similar. Okay, almost the same, right? Look at the shaded region, line here, everything. But the catch here is that you see there's a dark line above here, there's a dark line below here, right? Now the dark line below here tells me the stable nuclei here, and if the number of neutrons here increases beyond this number of neutrons present on the dark line, that means in this valley, then this valley will show you unstable nucleus. That's what it says. Which graph shows a line of stable nucleus? This line shows a stable nucleus over here, and the shaded regions above this one will have a much more larger number. Larger when the number of neutrons exceeds beyond a given threshold. Okay, for a given proton number, for this particular proton number, it should have only this much amount of neutron number. But if it exceeds beyond it, let me just increase this, zoom it across. See, if it exceeds it beyond this value, see the regions, the nuclei which are having this one here. Okay, if it exceeds beyond this and so on, beyond the dark line over here, this will become unstable. So therefore D is the right option. Okay, I hope you understand this. Okay, let us move on to the next.